How did Vikings stay warm while sleeping, even during the coldest winter nights when temperatures plunged so low that breath froze instantly, when exposed skin turned black with frostbite in minutes, when the world outside became a killing field where survival measured in hours, not days? These discoveries by historians are shocking everyone who thought they understood Viking life, because what archaeologists have found reveals a survival system so sophisticated that it challenges everything we assume about medieval technology and human endurance in extreme cold. Before we reveal exactly how Vikings managed to sleep warmly through nights that should have killed them, drop a comment with where you're watching from. And if stories of ancient survival technology fascinate you, hit that subscribe button, because what you're about to learn will change how you think about cold weather survival forever. Picture this: 9th century Scandinavia in the depths of winter. Outside, an Arctic blizzard rages with winds exceeding 80 kilometers per hour. The temperature has dropped to -30 degrees Celsius, and in some regions even lower. Temperatures where unprotected human beings die within an hour. Snow covers everything in sight, piling in drifts higher than a man's head. The darkness is nearly complete. During the polar night, the sun doesn't rise for weeks, leaving the world in perpetual twilight broken only by occasional starglow reflecting off endless ice. Inside a Viking longhouse, dimly lit by a flickering central hearth, dozens of people are preparing for sleep on simple wooden benches. They have no modern insulation, no central heating systems, no down comforters filled with goose feathers, no electric blankets, no thermostats. The walls are made of turf and wood. The floor is packed earth. The windows are essentially non-existent, just narrow slits that leak cold air. By every modern standard, this structure should be a death trap in these conditions. Yet when morning comes, these people wake up alive. Not just surviving, but functional, ready to work, to fight, to sail across frozen seas. It wasn't luck. It wasn't just toughness or genetic adaptation. It was a complete survival system elevated to an art form, a technology so effective that when modern researchers attempted to recreate it using only period-accurate methods and materials, they were stunned by the results. Their methods were ingenious in their simplicity and based on deep understanding of materials, the physics of heat retention, and the power of communal survival. They turned their icy dwellings into warm refuges capable of withstanding the harshest winters in human history. And very few people today know how they actually did it. The truth is shocking because it reveals that Vikings understood principles of thermal engineering that wouldn't be formally documented by science for another 1,000 years. They created what was essentially the world's first passive heating system, the first sleeping bags, the first multi-layer insulation technology, all using nothing but natural materials and observation honed over generations of deadly trial and error. Watch this to the end to find out what engineering tricks and survival techniques allowed Vikings to sleep warmly while ice storms raged outside, and why these methods still work today in survival situations where modern technology fails. What if everything you've been told about Viking longhouses is incomplete? The famous Viking dwelling wasn't just a building, it was an ingenious machine designed for one purpose: preserving human life in conditions that killed unprepared people within hours. Every single architectural detail, from foundation to roof peak, was the result of centuries of brutal experimentation where design flaws meant entire families froze to death. We tend to imagine these structures as huge, drafty halls, the kind you see in movies with high ceilings, wide open spaces, and dramatic fires burning in the center. That's almost completely wrong, especially for the regions where winter survival was most critical. In Iceland, Greenland, and the northern reaches of Scandinavia where temperatures were most extreme, longhouses were partially or completely dug into the ground. This single design decision solved multiple problems simultaneously. First, it eliminated wind exposure. The buried portions of the house were protected from the howling Arctic gales that could strip heat from exposed structures in minutes. Second, it used the earth itself as insulation. Below the frost line, ground temperature remains relatively constant even when surface air drops to deadly lows. By sinking the house into this stable thermal zone, Vikings created a natural buffer against temperature extremes. But the real genius was in the walls. These weren't simple wooden planks like you'd find in other medieval structures. Viking walls in the coldest regions were massive barriers of turf, thick blocks of earth held together by dense root systems, cut from marshy soil and stacked in layers. Some of these walls measured up to 5 feet thick. 5 feet of solid insulation between the living space and the killing cold outside. The turf itself had unique properties that Vikings understood through observation, even if they couldn't explain the physics. The dense root system held soil together while creating thousands of tiny air pockets throughout the material. Air, specifically trapped, still air, is one of nature's best insulators. Those microscopic pockets prevented heat transfer far more effectively than solid wood or stone ever could. In winter, when snow accumulated on the turf roof and walls, the insulation became even more effective. Snow itself is an excellent insulator due to the air trapped between ice crystals. A longhouse covered in thick snow became, essentially, a well-insulated cave where internal heat had almost nowhere to escape. The roof was equally sophisticated. Vikings didn't just throw some planks overhead and call it finished. The roof was multi-layered with each layer serving a specific function. First came wooden rafters for structural support. On top of these, they laid birch bark, not for insulation, but for waterproofing. Birch bark is naturally water-resistant, preventing rain and snowmelt from penetrating into the living space where moisture would become deadly cold. On top of the birch bark came 2 or 3 layers of turf, creating the same insulating effect as the walls. The turf protected from wind and cold from above, while adding structural weight that helped the whole roof resist being torn off during violent storms. Even the orientation of the house was calculated. Vikings built longhouses so that the narrow end walls faced the prevailing winter winds. This meant the minimum surface area was directly exposed to the most powerful thermal assault. The long sides, protected by their massive turf thickness, presented less direct exposure to wind-driven cold. Inside, the space was meticulously organized for thermal efficiency. The central area contained the hearth and main activity zone. But the sleeping areas, called paler, were wide raised platforms running along both sides of the house. These platforms elevated sleepers approximately 1 meter above the floor, and this seemingly small detail was critical for survival. Cold air is denser than warm air, so it sinks and accumulates at ground level. The floor of a Viking longhouse was the coldest zone in the entire structure. Sleeping on the floor would mean sleeping in a pool of freezing air that would kill you through conductive heat loss. By raising the sleeping platforms a meter up, Vikings positioned themselves in the warmer air zone while leaving the deadly cold layer below them. The longhouse had virtually no windows as we understand them. Any opening was a catastrophic source of heat loss. A single modern window can account for 25% of a home's heat loss. Vikings couldn't afford that luxury. Lighting came primarily from the central hearth fire and from seal oil lamps. Ventilation came through a smoke hole in the roof and through carefully managed doorways that could be sealed tight against drafts. This architecture wasn't about comfort or aesthetics. It was about maximum thermal efficiency using only natural materials. The longhouse was a collective refuge, a survival machine where every element worked together to trap and preserve the precious heat generated by fire and human bodies. Now, if you're already fascinated by this lost Viking engineering, make sure you're subscribed because we're about to reveal the actual heating system that kept these people alive through the coldest nights. At the very center of the longhouse, stretching along its entire length, was the langold, the long hearth. This wasn't a fireplace as we know it, or even a traditional hearth. It was something far more sophisticated, a distributed heating system designed specifically for the elongated shape of Viking dwellings. Structurally, the langold was a long, shallow trench dug directly into the earthen floor and lined on both sides with flat stones. But here's what made it ingenious. The hearth wasn't a single fire burning in one spot. It was a continuous fire channel that could stretch 10, 15, even 20 meters across the entire length of the house. This elongated design was critical. A Viking longhouse was narrow but extremely long, sometimes 30 meters or more. A conventional round hearth burning in the center would heat the middle section adequately but leave both ends of the house freezing and uninhabitable. The langold solved this problem by distributing heat along the entire central axis, creating an extended warm zone that reached every part of the dwelling. Different sections of this long hearth served different families living in their designated areas along the walls. Each family group had access to their portion of the communal fire for cooking, warmth, and light. It was communal infrastructure that prevented anyone from being left in deadly cold. The stones lining the hearth weren't decorative, they were thermal batteries. Throughout the day as the fire burned, these stones absorbed tremendous amounts of heat. Stone has high thermal mass, meaning it takes a long time to heat up but also a long time to cool down. Even after the flames diminished at night to conserve fuel, the heated stones continued radiating warmth for hours, maintaining survivable temperatures through the coldest parts of the night when the fire burned lowest. The hearth was multifunctional in ways that reveal how every element of Viking life was optimized for survival. It was simultaneously the cooking system. Large metal cauldrons hung from ceiling chains above different sections of the fire, simmering soups and porridges for hours. It was the light source in a dwelling with essentially no windows, allowing work to continue during the long polar nights. And critically, it was the primary heat source around which all life in the house revolved. Keeping this fire burning was not optional. It was a sacred duty, a survival imperative that never stopped. An extinguished hearth in winter meant death for everyone in the house within hours. Someone, often women or enslaved people, maintained constant vigilance over the fire. At night, they employed a technique that reveals sophisticated understanding of combustion management. Rather than letting the fire burn out completely, they covered the hottest coals with a thick layer of ash. This smothered the flames but allowed the coals to continue smoldering slowly, producing minimal smoke while preserving the ember core. In the morning, it took only moments to remove the ash layer, add dry kindling, and fan the coals back into full flames. This was infinitely easier than starting a fire from scratch with flint and steel, a process that could take 30 minutes or more in cold, damp conditions. This constant burning provided stable baseline heating. But it created a terrible paradox that Vikings had to accept as the price of survival. Warmth required smoke, and smoke was slowly poisonous. The brutal reality of Viking winter survival was a constant choice between two forms of suffering. You could open the smoke hole wide and breathe clean air while freezing to death, or you could seal the house tight, stay warm, and slowly suffocate in toxic fumes. Vikings chose warmth and accepted the consequences. The interior of a longhouse was perpetually filled with smoke. Not occasionally, constantly. Every single day and night, thick wood smoke hung in the air like fog. The smoke hole in the roof vented some of it, but opening it too wide meant losing precious heat, so the balance was always tilted toward keeping warmth in rather than letting smoke out. Archaeological evidence confirms this wasn't just uncomfortable, it was genuinely toxic. During excavations of longhouse sites, scientists find thick layers of soot coating everything. Analysis of preserved wooden structures shows that combustion products penetrated centimeters deep into the wood grain. The walls, ceiling beams, sleeping platforms, everything was coated in a sticky, greasy black layer that accumulated over years and decades. Studies of human skeletal remains from Viking-age Scandinavia frequently reveal chronic respiratory diseases. Chronic bronchitis, emphysema, and lung damage consistent with long-term smoke inhalation are common findings. Eye problems from constant irritation appear in historical accounts. Women and children, who spent the most time indoors near the hearth, suffered the worst effects. By modern air quality standards, the atmosphere inside a Viking longhouse would be classified as immediately dangerous to human health. The concentration of carbon monoxide, carcinogens, and particulate matter was extreme. But the choice was simple and brutal. Suffer chronic lung problems that might kill you in 40 or 50 years, or freeze to death tonight. Vikings chose survival. They lived in that poisonous murk because the alternative was ice and death. But fire alone wasn't enough. The hearth heated the air, yes, but air is a poor conductor of heat to the human body. You can sit in a warm room and still feel cold if the surfaces you're touching, the floor, the bed, the walls, are freezing. Vikings understood this instinctively, and they developed a technology to solve it that was nothing short of brilliant. They created what we would today call radiant floor heating or heated sleeping surfaces, except they did it 1,000 years before modern technology using nothing but stones and fire. The stone heat battery. Viking thermal engineering. The problem was obvious but deadly. The langled fire burned in the center of the hall, radiating heat into the air. But the sleeping platforms were positioned near the cold outer walls, sometimes 3 or 4 meters away from the flames. Even if the air in the house felt relatively warm near the fire, the wooden platforms and beds themselves remained icy. Going to sleep on a frozen surface meant guaranteed hypothermia. Your body would lose heat through conduction faster than it could generate it, and you'd wake up dead or severely frostbitten. Vikings solved this with a technique that reveals genuine understanding of thermal physics. They used heated stones as portable heat sources that continued radiating warmth long after being removed from the fire. Throughout the day, while the langled burned, large flat stones were positioned in or directly beside the flames. These weren't random rocks grabbed from outside. They were specifically selected stones known from experience to have high heat capacity and resistance to thermal shock. Certain types of granite, soapstone, and dense river rocks could absorb enormous amounts of thermal energy and release it slowly over many hours without cracking from the temperature stress. In the evening, when families prepared for sleep, these scorching hot stones were carefully extracted from the hearth using wooden tongs or thick pieces of leather wrapped around the hands for protection. This was dangerous work. A dropped stone could shatter and send razor-sharp fragments flying, or cause severe burns. But it was essential. The heated stones were then placed in strategic locations under and around the sleeping platforms. Some were positioned in carved-out niches beneath the wooden planks. Others were simply set on the earthen floor directly under the platform. The principle was elegant. Heat rises. The thermal energy radiating from the stones would slowly rise upward, warming the thick wooden planks from below and transforming the icy sleeping surface into a comfortable, warm bed. This was localized, targeted heating that didn't waste energy trying to warm the entire massive volume of air in the longhouse. It specifically heated the exact place where people would spend the next 8 to 10 hours. The thermal efficiency was remarkable. A properly heated stone bed could remain comfortably warm for 6 to 8 hours, often enough to last through the coldest part of the night. But there was an even more personal application of this technology. Smaller stones were also heated in the hearth, then tightly wrapped in several layers of thick wool fabric or old leather to prevent burns. People took these improvised heat packs directly into bed with them, placing them at their feet or pressing them against their bodies. A hot stone wrapped in wool was essentially a medieval hot water bottle, and it was astonishingly effective. The stone would radiate gentle warmth for hours, helping people fall asleep comfortably even when the air temperature in the longhouse dropped near freezing toward morning when the fire burned lowest. This hot stone technology required constant labor. Stones had to be monitored, heated at the right time, moved safely, and replaced as they cooled. But the result was the difference between survival and death. It's a striking example of how Vikings used basic physics to solve critical problems without any formal scientific education, just generations of observation and refinement. Yet stones alone couldn't keep people warm. The real miracle material that made Viking winter survival possible was something they valued more than silver, more than iron, more than almost any other resource: wool. Wool, the strategic resource that built an empire. If you asked a Viking what single resource was most critical for winter survival, they wouldn't say food or fire or shelter. They would say wool. This seemingly simple material was the foundation of Norse civilization's ability to survive and expand into the harshest climates on Earth. The wool produced by northern European sheep breeds raised by Vikings had unique properties that made it superior to almost any other natural insulation material. The fibers consisted of 2 distinct types: long, durable, water-resistant outer guard hairs called tog, and incredibly warm, soft inner undercoat fibers called fell. But the true miracle was lanolin, a natural oil produced by sheep that coated every single fiber. Lanolin made Viking wool virtually waterproof. It repelled moisture whether from rain, snow, or the oppressive humidity inside a smoke-filled longhouse. This was critical because wet insulation is worse than no insulation. Moisture conducts heat away from the body 25 times faster than dry air. Thanks to lanolin, woolen clothing and bedding remained warm even when damp. A person could work outside in falling snow, come inside with moisture clinging to their wool cloak, and the garment would continue insulating effectively while slowly drying by the fire. No other natural material available to Vikings had this property. Wool processing was one of the primary winter occupations, consuming vast amounts of time and labor. After spring shearing, the wool had to be washed to remove dirt while preserving enough lanolin for water resistance. Then it was sorted, coarse outer fibers separated from soft undercoat. The fibers were combed to align them, then spun into thread using drop spindles, a process so time-consuming that producing enough thread for a single cloak could take weeks. The coarse outer fibers had their own critical uses. They were woven into the most durable items: sails for ships, ropes, fishing nets, and heavy outer cloaks designed to break the wind. Viking expansion across the North Atlantic was literally powered by wool sails. Without them, their ships couldn't have made the voyages that discovered Iceland, Greenland, and North America. But for sleeping warmth, Vikings used the soft inner undercoat. These finer threads were woven into dense, thick fabric on vertical looms. The weaving process was slow and required skill, but the result was worth every hour of labor. The key fabric for winter survival was called vamel, a dense, heavy woolen cloth that underwent a special treatment after weaving. The fabric was fulled, meaning it was beaten and rubbed vigorously in hot water. This process caused the fibers to mat together even more tightly, creating material similar to modern felt. Fulled vamel was nearly impervious to wind and had phenomenal insulation properties. This fabric became so valuable in Iceland that it was used as currency. Literally, people traded in standardized units of vamel. It was used to make everything from pants and tunics to blankets and wall hangings that added extra insulation to longhouse interiors. Wool was everywhere in Viking sleeping arrangements. It stuffed pillows and mattresses. It was woven into blankets. It was even used to plug gaps and cracks in walls to prevent drafts. Without this versatile material, survival in Scandinavian winters would have been nearly impossible. But having wool wasn't enough. Vikings had to use it correctly. And this is where their understanding of layering becomes truly impressive. The multi-layer sleeping system, engineering a survival cocoon. A Viking sleeping area wasn't simply a bed as we understand the term. It was a carefully engineered multi-layer insulation system where each component served a specific, irreplaceable function. Understanding this system reveals just how sophisticated their survival technology actually was. The foundation was the paler, the raised wooden platform we discussed earlier. Critical point: it elevated the sleeper approximately 1 meter above the deadly cold air pooling on the floor. But sleeping directly on bare wood would still drain body heat through conduction. So the first layer on top of the wooden planks was a thick cushion of dry organic material. Usually this was straw, not just scattered randomly, but laid down in a thick, intentional layer 15 to 20 centimeters deep. Sometimes dried moss, heather, or fir branches were used instead or in combination with straw. This organic layer served dual purposes. It provided cushioning, functioning as a primitive mattress spring. But more importantly, it created thousands of tiny air pockets between the dried stems and branches. Trapped air is one of nature's best insulators, and this layer prevented the cold from the wooden platform from rising to the sleeper's body. It also helped absorb moisture from perspiration, keeping the sleeping area dry. On top of this plant material came processed animal skins, usually placed with the fur side facing down. The tough leather side created a durable, wind-proof barrier, while the fur added another insulating layer of trapped air. This skin layer also prevented the straw beneath from poking through and making sleep uncomfortable. Over the skins went thick felt or several layers of coarse vamel. This was the actual mattress as Vikings understood it. Its purpose was to provide additional softness while completely insulating the sleeper from any residual cold rising from below. Only on top of this complex foundation were the actual bed linens laid. These were sheets made of softer woolen fabric or, for wealthier families, linen. Linen was prized for hygiene because it could be washed more easily than wool, but wool was warmer for the coldest nights. The covering system was equally sophisticated. Vikings didn't use a single thick blanket, they used multiple layers. The person sleeping would first cover themselves with their own heavy woolen cloak. These cloaks were large rectangular pieces of extremely dense fabric, perfect for doubling as blankets. If temperatures dropped further, additional layers were added, perhaps another heavy blanket woven from vamel, or multiple lighter coverings. The principle was the same as with clothing. Layering traps air between each layer, and that trapped air provides insulation far superior to a single thick covering. This entire system created a thermal cocoon. It wasn't designed to heat the surrounding space, that was impossible and wasteful. Instead, it trapped and preserved the minimal heat generated by the human body itself, preventing it from escaping into the freezing air. Every element from straw to cloak was part of a unified survival strategy refined over centuries. And when wool and layers still weren't enough during the absolute coldest nights, Vikings had one more weapon: fur. Fur, the ultimate insulator. When temperatures plunged to truly deadly levels, nights when even the layered wool system struggled, Vikings turned to the most effective natural insulator known to humanity: animal fur. Processed skins with long, thick fur were incredibly valuable. Bear, wolf, seal, and reindeer furs were especially prized for their insulating capacity. These weren't just luxury items, they were life-saving tools. Large fur pelts were sewn together to create massive blankets capable of covering multiple people at once. Fur's effectiveness comes from its ability to trap enormous amounts of air between individual hairs. This trapped air, warmed by body heat, creates an insulation barrier that's genuinely difficult to match even with modern materials. The weight of these fur blankets also mattered. They fit snugly against the body and other bedding layers, eliminating air gaps where cold drafts could penetrate. This created a sealed thermal environment where body heat had almost no escape route. But Vikings developed something even more sophisticated, mentioned in the sagas: the fat, which translates roughly as leather bag or skin bag. This was essentially a sleeping bag sewn from multiple large pelts with the fur facing inward. A person would climb into this bag completely, leaving only their head exposed. The neck opening could be tightened with a drawstring to seal out cold air. Inside this fur cocoon, even when the longhouse temperature dropped near freezing, a person could sleep comfortably warm. This was particularly critical for travelers, warriors on campaign, or anyone sleeping alone without the benefit of shared body heat. The fat was personal protection against the cold, a portable survival system that went wherever its owner went. Archaeological evidence and saga descriptions confirm these sleeping bags existed and were highly valued. They represent some of the earliest examples of what we'd now recognize as wilderness survival gear: portable, self-contained thermal protection. The clothing strategy: never sleep in what you wore. There's a persistent myth that medieval people slept naked or nearly so. For Viking-age Scandinavia, this would have been suicidal. But they also didn't sleep in their daytime clothes, that would have been almost as deadly. The reason reveals sophisticated understanding of moisture management. Daytime clothes, even if they seemed dry, were saturated with perspiration and moisture from the humid longhouse air. Wool can absorb up to 30% of its weight in water while still feeling relatively dry to the touch. But moisture conducts heat away from the body rapidly. Sleeping in damp clothes was the fastest way to develop hypothermia. Your body would spend all night fighting the thermal drain from wet fabric, exhausting itself and potentially failing by morning. Therefore, before bed, everyone changed into dedicated sleep clothing that was kept dry and clean. Daytime garments were carefully hung near the hearth to dry overnight, ready for the next day. Sleep clothing started with a long linen undershirt or surca, a tunic-like garment reaching to the knees or ankles. linen was preferred next to skin because it wicked moisture away from the body while being softer than wool. Over this, if nights were particularly cold, went a looser woolen tunic. This combination, linen for moisture management, wool for insulation, was the ideal layering system. Crucially, Vikings never slept with uncovered heads. Modern science confirms that up to 30% of body heat can escape through an uncovered head due to intense blood flow to the brain. Vikings understood this from experience. Sleeping with a bare head in a freezing longhouse was a sure way to wake up dangerously cold. Everyone wore woolen caps or hoods to bed. These fit snugly around the head, covering the ears completely. Ears are particularly vulnerable to frostbite and heat loss, so protecting them was essential. This careful attention to sleep clothing wasn't about comfort, it was about survival. The right clothing kept people warm enough to sleep deeply, allowing their bodies to rest and recover for the next day's brutal labor. The secret weapon: shared body heat. Perhaps the most effective survival technique Vikings employed required no materials or technology at all. It was completely free and available to everyone: the warmth of other human bodies. In Viking culture, which emphasized extended family and collective living, sleeping together wasn't unusual or uncomfortable, it was basic survival strategy and social norm. The sleeping platforms weren't designed for individual privacy. They were wide communal sleeping surfaces, sometimes 2 to 3 meters across, stretching the entire length of the longhouse wall. Multiple generations slept on these platforms side by side. Elderly grandparents, adult children with their spouses, young grandchildren, all together. The physics are simple but effective. One human body generates approximately 100 watts of heat. Two bodies generate 200 watts but don't lose heat twice as fast because they're in contact with each other. The surface area exposed to cold air is reduced. Bodies act as mutual heat sources, warming each other. Family members bedded down together deliberately, huddling close to share warmth. They also shared bedding. It's far more thermally efficient to cover 3 or 4 people with one massive fur blanket than to cover each person separately. Under a communal blanket, a single warm microclimate is created and maintained by collective body heat. This method was especially critical for protecting the most vulnerable: the very young, the elderly, and the sick. In this communal system, no one froze alone. The weakest members could always rely on the warmth of the stronger, healthier family members sleeping beside them. There are no complaints about this practice in sagas or historical accounts. It wasn't considered crowded or uncomfortable, it was as natural as breathing. The warmth generated by several bodies was often the deciding factor in survival during the coldest nights when the hearth fire burned low and stone heaters cooled. Thus, Viking social structure, based on extended family living, was directly integrated into their cold weather survival strategy. They survived not as individuals but as a single warm organism. Fueling the internal fire, food as survival tool. Survival in extreme cold isn't only about external insulation. The human body is a metabolic furnace that must be constantly fueled. Vikings understood this perfectly, and their winter diet was specifically designed to maximize internal heat generation. The Viking winter diet was extremely high in calories, particularly from fats and proteins. Fatty fish, dried, smoked, or preserved in other ways, was a staple. So was meat from sheep, cattle, pigs, and game. Animal fats weren't avoided as unhealthy, they were the primary source of concentrated energy. Fat is metabolically slow-burning fuel that breaks down gradually, releasing steady heat for many hours. This made it perfect for nighttime. Eating fatty food before bed meant your body would continue generating heat while you slept. Carbohydrates came from whole grain porridges made from barley or rye, plus root vegetables like turnips. These provided quick energy for daytime work. But the final meal before sleep was especially important. It was almost always hot, thick soup or rich porridge eaten just before going to bed. Hot food served two purposes. It physically warmed the body from inside, and it started the digestive process, which itself generates heat through metabolic activity. Hot drinks were equally important. Vikings drank herbal teas and warmed ale, not the strong alcoholic drink we know today, but a thick, nutritious beverage more like liquid bread that provided warmth and calories. This internal metabolic fire was as essential as external wool and fur. The body needed fuel to generate its own heat. Without proper nutrition, even the best bedding couldn't prevent hypothermia. Conclusion: a complete survival system. Surviving the coldest winter nights wasn't the result of any single trick or technique. It was a complete, integrated system where architecture, material science, thermal engineering, nutrition, and social structure all worked together. From longhouses partially buried in earth with 5-foot-thick turf walls, to the distributed heating of the langled hearth, to hot stones radiating warmth under sleeping platforms, to wool processed and layered with sophisticated understanding of insulation principles, to communal sleeping that maximized shared body heat, every element reinforced the others. The Vikings proved that human ingenuity can overcome seemingly impossible environmental challenges. They survived and thrived in conditions that kill unprepared people within hours, using nothing but natural materials and knowledge refined through generations of brutal experience. Their methods still work today. In survival situations where modern technology fails, these same principles, layering, moisture management, thermal mass, communal warmth, proper nutrition, remain as effective as they were 1,000 years ago. The warmth that kept Vikings alive through the coldest nights in history wasn't magic or superhuman toughness. It was engineering, observation, and the understanding that survival is a daily, methodical struggle where no detail is insignificant.